Hello friends, welcome to my YouTube channel. My name is Akhil Jain and I am from Maths Made Magical. Today I am going to be teaching NCERT Grade 6 Mathematics Chapter 5 Prime Time. So when we learn about prime time, it is not about the great ages of people or something like that. Prime time basically means prime numbers and the various concepts related to it. So without further ado, let's move on. And before we begin with the video, please like, share and subscribe so that you can get many more videos like this and understand all your maths concepts better. Before we move on with the new concepts of the chapter, let us solve the challenge of the previous chapter. This question was given in my previous video of chapter 4 data handling and presentation. This was the question I have given before, and now I have given the answer in this video as I have said before. Please take a screenshot and you can check the answers afterwards. Every year, Bright Minds International School holds a book fair where students of classes 6, 7, 8, 9 visit different book stalls. That year, there were four stalls: uh, storybooks, science books, comics, and magazines. So, the number of books sold each day was recorded as follows. Sorry. Now, the first question was find the total number of books sold for each type across all the 5 days. For storybooks, it is 25 plus 30 plus 35 plus 35 plus 40, 165. Science is 15 plus 25 plus 30 plus 30 plus 35, 135. Then for comics, we have 35 plus 25 plus 30 plus 25 plus 40, 155 comic books. And for magazines, we have 20 plus 20 plus 25 plus 15 plus 30, 110. And if we arrange the books in descending order, it is storybooks, comic books, science books, and magazines. Now, pictographs and bar graphs are something you have to draw by yourself. And debit we will discuss now. Which stall sold the maximum number of books? And what is the ratio to total number of books? The answer is storybooks sold 165 and the ratio is 165 by what is the total? 165 by the total must be 165, 135, 155, 110. 565. So 135 by 565, 33 is to 13. So that is the ratio. Next, which stall sold the minimum number of books and what is the ratio to total number of books? The answer is magazine, which is 22 is to 13. Next, on which day were the most number of total books sold in all the stalls? Friday. And how many books that day? 145. If each science book costs 80 and each storybook costs 75, which stall earned more money? Then storybook must have cost 9075 and science book must have cost 10,800. So the difference is 1725 and science book costs more. And if each comic costs 50 and each magazine costs 60, then which stall earned more money? For that one is 7725 for comic books, and for magazines we have 6600. So difference will be of 1150. 7250 and 6600, so 1150 for comic books. And what is the total money acquired by all the shops is 34,225, and the ascending order is magazine, comic book, storybook, and then science book. Now, please take the screenshot of these answers so that you can refer later. Thank you. Now, What we will learn in this chapter of chapter 5 prime time is common multiples, common factors, prime and composite numbers, co-prime numbers, prime factorization, the uses of prime factorization, and divisibility tests. And finally, I will give my very own chapter challenge, which I will give the answers for in the next video. So, the first topic is common multiples or the multipliers. Basically, what is a multiple? A multiple of a number is what you get when you multiply it by 1, 2, 3, 4, etc. So, if we have 5 table, 10 is multiple of 5 because 10 is 5 into 2. And then 15 also, 5 into 3, 20, 5 into 4, and so on. So, a common multiple of two or more numbers is simply a number that appears in all their multiple lists. Now, 4 table is 4, 8, 12, 16, and 20. 5 table is 5, 10, 15, 20, 25. We can see that 20 is repeated in both of them. So, we can say that the common multiples of 4 and 5, one of them is 20. And after 20 you can get 40, 60, 80, and so on. So to find the common multiple of two numbers, we need to first write the multiples. We need to write their multiplication table, and we have to look for numbers that are in both the numbers. In both the multiple lists we have to look for the numbers, and then we have to write them down. Here we have given one more example. Multiples of 4 is 4, 8, 12, 16, 20, 24. And then multiples of 6, 6, 12, 18, 24, and 30. Now the common multiples are 12 and 24, 36, 48, and so on. And one astonishing thing is that the common multiples list is there. All the common multiples, when they are combined, they make their own multiplication list. So they make their own multiplication table. And one more important point we have to learn about common multiples is LCM or least common multiple, which is the smallest common multiple between two or more numbers. For example, multiples of 2 are 2, 4, 6, 8, 10, 12, 14. For 3, 3, 6, 9, 12, 15, 18, 21. So the common multiples, the first one is 6. The first common multiple is 6. So the LCM is 6. Now, let's practice what we have learned until now, and let's do these questions. Now, before I give you the answers, please take a screenshot of this. Thank you. Now, the first bit is list the first 5 common multiples of 3 and 5. Shall I tell you one trick? What is 3 into 5? 3 into 5 is 15. So, the first 5 common multiples will be 15 table, which is 15, 30, 45, 60, and 75. It is as simple as that. It is very simple. We do not need to worry, because if we write all the multiples and then we see which one is common in all of them, it's very tiring. And since we know multiplication, it's very simple to write 3 and 5 into and then continue with that. Next, a light blinks every 4 seconds and another light blinks every 6 seconds. So after how many seconds will they blink together again? For this we have to find the LCM. So what is the multiples of 4? 4, 8, 12, 16. And for 6 is 6, 12, 18. So 12 is common. So they both the lights will blink at one time after 12 seconds. Next, write the first 3 common multiples of 7 and 9. Simple. 7 into 9, 63. 63 into 2 is 126. 126, 63 into 3 is 189. Simple. Done. First 3 common multiples. State true or false. If 60 is a common multiple of two numbers, then both numbers must divide 60 exactly. Because it is true, because if something into something is 60, then that number can divide it because it is being used to multiply it. Next, two friends jog around a circular track. Rohan completes a lap in 12 minutes, whereas Asha completes a lap in 15 minutes. If they start together, after how many minutes will they be at the starting point at the same time? And now, at the starting point at the same time. Yeah, for this we have to Write the common multiples: 12, 24, 36, 48, 60, 15, 30, 45, 60. 60 is common, so they will meet again at 1 hour. I actually forgot to tell you, we can do the product. We can do the product of 3 and 5 and 7 and 9, but it is not applicable for all the numbers. Suppose if we take 2 and 4, the multiplication list of 2 and 4 is 2, 4, 6, 8. So 4 will also come. After 4, 8 will come. But if we do the multiplication way, then it starts from 8. So that is wrong. We can only use LCM when both the numbers are prime numbers. When both the numbers are prime numbers, we can use that multiplication method instead of doing the LCM. Here 3 and 5 are prime numbers, and for 7 and 9, 7 is prime number. Even if you have one prime number, it's okay. 7 is there and 9, so 63 is common, like that. We cannot use the product all the time. And how many laps would Rohan and Asha have completed by the time? 60 comes the fifth number in 12. So Rohan would have completed 5 laps and Asha would have completed 4 laps. Now let's move on to the second topic of this chapter, common factors. Common factors are like the opposite of common multiples. Common factors are dividers, whereas common multiples are multipliers. First, we need to know what a factor means. A factor of a number is something that divides it perfectly. So it's a divisor. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12. So 12 by 1 is 12, 12 by 2 is 6, 12 by 3 is 4, 12 by 4 is 3, 12 by 6 is 2, and 12 by 12 is 1. So these factors are dividing it exactly into whole numbers. That is why they are called factors. So a common factor of two or more numbers is simply a factor that appears in every list of their factors. So suppose we take two numbers and there is one number which can divide both of them. That number is common factor. So finding it is like a piece of cake, which means it's very easy. For example, the factors of 20 are 1, 2, 4, 5, 10, 20. And the factors of 28 are 1, 2, 4, 7, 14, 28. So the common factors, we can see that 1, 2, 4 are there in both of them. So the common factors are 1, 2, and 4. And there's a fun fact that we can find common multiples and factors using PFM, which means prime factorization method also. One more important thing we need to learn is highest common factor, HCF, which means the highest or largest common factor between any two or more numbers. Suppose we take 44 is 1, 2, 4, 11, 22, 44. And for 24 it is 1, 2, 3, 4, 6, 8, 12, 24. So we can see that 1, 2 and 4 are common in both of them. So between 1, 2 and 4 the greatest one is 4. So the HCF is 4. Now let's practice what we have learned until now. A craft teacher has 48 red ribbons and 60 blue ribbons. She wants to make identical bundles using all the ribbons having the same number of red and blue ribbons. So here what we can do is we need to find the HCF. So the highest number of bundles she can make. So 48 is 1, 2, 3, 4, 6, 8, 12, 24, and 48. And 60 is 1, 2, 3, 4, 5, 6. 8 is not there, so 10, and then 20, and 30, and then 60. So here we need to find the identical zones. So 1, 2, 3, 4, 6, and that's it. So 1, 2, 3, 4, and 6 are same. So 1, 2, 3, 4, and 6 are common factors. So the highest one is 6. So the answer is 6. She can make 6 identical bundles. Next, a school needs to arrange 72 students and 90 teachers in rows for group photograph. Each row must have same number of students and teachers with no one left out. What is maximum number of rows they can form? For this one we have to do 62. So 1, 2, 3, 4, again 6, 8, 9, 12, and then 18, 18, 24, and 36 and 72. And then 90 is 1, 2, 3, 4 won't come, so 5, 6, and then 8 also won't come, 9, 10, and then 15, and then 30, 45, and 90. So what we can find common is 1, 2, 3, 6, 9, and that's it. So 1, 2, 3, 6, 9. So maximum number of rows, the biggest one, 9 is the answer. Next, farmer has 84 green apples and 108 red apples. So 84 is 1, 2, 3, 4, and then 6. So 9 won't come, 12, and then 24 won't come. No, 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 no. And then 21, 42, and finally 36 is also there. No, 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 no. 28 is there. Yes, and yeah, 20, 21, 28, 42, and then 84. Next, 108, we have 1, 2, 3, 4. You know what? You know how to find the HCF anyway. So I suggest you do all these yourself. It's actually very long if you do not have a calculator beside you, but I am sure you're going to be able to do it. For now, you know the concept. So, yeah. And anyways, I do not have the process to show you. So just take the screenshot. These questions are long, that's why I am having to give them to you. I will try to solve the others definitely. Thank you. Now let's learn about prime and composite numbers, which are probably the biggest concept of this chapter. So a prime number is a number which has only two factors. We have learned about factors already. So a prime number is a number which can be divided only by 1 and itself. Suppose we take 13. 13 can be divided by 13 1, and 13 can be divided by 1, which is 13. So 13 is a prime number. And composite number is the opposite. It is a number which has more than two factors. Suppose if we take 12, 12 can be divided by 1, 2, 3, 4, and 6, and 12 also. When it has these many factors, it's not a prime number, it's a composite number. So 1 has only one factor, just itself. So it is not prime or composite. And to identify them, we have to try dividing the numbers by smaller ones like 2, 3, 5. And if nothing divides it evenly, except 1 and itself, it is prime. And if something else divides it, it's composite. And 2 is the only even prime number, and all other prime numbers are odd numbers. Now, let's practice these questions. A school is printing badge numbers from 1 to 36. How many of these numbers are prime and how many of these numbers are composite? Now we know that 1 is neither prime nor composite. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and so 37 won't come because still 36. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 prime numbers. And then if we count the rest of them other than 1, so we will have 35 minus 12. 35 minus 12 is 23. So 23 composite numbers and 12 prime numbers. Next, a fruit seller packs oranges in groups of 7. He wants to know if the number 49 is prime or composite. So he can decide whether it can be arranged in neat rectangular row. What is 49, prime or composite? We know that 49 is 7 into 7, so 49 is composite number. At an art show, the tickets are numbered. One ticket shows 57. Organizer wonder whether it's prime or composite. Is 57 prime or composite? The answer is it's composite because 57 is 19 into 3. Next, a box contains 91 marbles. The shopkeeper wants to pack them equally into rows for display. Can he do it? No, because uh, 91 is a prime number. It cannot be divided by any other number than itself. So it cannot be packed equally. A lock for a treasure box uses a two-digit code. The only clue given says that it's a prime number between 30 and 50. List all the possible codes that the lock could have. Now, between 30 and 50, the numbers are 31, 37, and 41, 43, and 47. So, 5 codes. Next, a classroom has 64 chairs. The teacher wants to arrange them equally in rows. She checks whether 64 is prime or composite. 64 is composite because it has many factors at 2, 4, 8, and those are enough. A jeweler has 73 beads to to make a necklace. 73 is prime number, so she can't make them into equal groups without leftovers. Shop sells packs of 28 stickers. 28 is composite, so he can make many different rectangular rows. It's not impossible, it's possible. Next, please take a screenshot of these questions. I know I'm telling you to take these screenshots for all these practice questions, but they are very useful for your exams. If you learn these, you basically know that whole topic perfectly. Now, co-prime numbers, which means two numbers are called co-prime or relatively prime numbers when the only common factor between them is 1 and they do not need to be prime. Suppose if we take 9 and 22. 9 has 1, 3. That's it. 1, 3 and 9. Whereas 22 has 1, 2 and 11 and 22. So here their common factors are only 1. So both of those numbers are co-prime. Here we have 8 and 15 also where the common factor is only 1. So 8 and 15 are co-prime. But if there are more than 1, if there is 2, if there is 3, if there is 4, they are not co-prime. So two prime numbers are always co-prime, and a prime and a composite number can be co-prime, and two composite numbers can also be co-prime. And another way to find out is through HCF. So if the HCF is 1, the numbers are co-prime, and if the HCF is more than 1, if it's 2, 3 or 4 and so on, they are not co-prime. Now, let's practice what we have learned. A gardener plants 14 tulips and 25 roses. She wants to display them side by side in equal groups. Check whether 14 and 25 are co-prime. 14's factors are 1, 2, 7, 14. 25 is 1, 5, 25. So only one is common, so they are co-prime numbers, so she cannot display them side by side in equal groups. Next, two cyclists take laps around a track. Ravi completes lap in 9 minutes, Arjun completes lap in 16 minutes. They wanted to know if their lap times have any common factor other than 1. Are their times co-prime? 1, 3, 9 for 9 and 1, 4, 16 for 16. So 1 is only common. Their times are co-prime. Next, 7 and 12, they are co-prime, so the answer is co-prime. 18 and 35, 5 and 7, no. Yeah, they are also co-prime. And 11 and 20, they are also co-prime. 27 and 44, they are also co-prime. So for all of them, the answer is yes, they are co-prime. But we have to show that. We have to show whether they are co-prime or not. They are co-prime. So I think we all know how to show them. We have to write the factors and we have to circle the one. Now please take a screenshot of this so we can continue. Thank you. Now, prime factorization, the most important concept of this chapter. Prime factorization means breaking a number down into the prime numbers that multiply to give it. Suppose if we take 27, 27 is 3 into 3 into 3. So 3's are prime numbers. So that is prime factorization. Dividing 27 into the numbers which multiply together to give 27. So that is called prime factorization. Basically expanding. When we were small, we used to expand 1000 numbers into 1000, 100, 10 and 1. Here the same thing, almost similar, but with multiplication. So there are two methods in 6th grade to learn how to uh, do prime factorization. The one is vertical tree method and the other one is repeated division method. So in vertical tree method, if we have 60, the simplest one we can get is 6 into 10, right? So 6 into 10 we draw it, and then 6 we know 2 into 3, 10 we know 2 into 5. Simply then we can write 60 is equals to 2 into 2 into 3 into 5. So proven. And next for 84, if we take it by 2 42, by 2 21, 21 cannot be divided by 2. So by 3 is 7, 7 is prime number, so by 7 1. So 2, 2, 3 and 7 proven. So those are the two methods we can use to do prime factorization. Now, let's practice these. And a shopkeeper has 84 chocolates. He wants to pack them into boxes. So 84 we just did now, 2 into 2 into 3 into 7. So that's the prime factorization. Next, teacher 90. 90 is 9 into 10. So 9 can be divided in 3 into 3 and 10 can be divided 2 into 5. So the answer is 3 into 3 into 2 into 5. Next, 72 is 9 into 8. So 3, 3 and then 2, 4 and then again 2, 2. So 3 into 3 into 2 into 2 into 2 is 72. Next, factorization is 2, 2, 3, 5, 5. So 2 into 2, 4, 4 into 3, 12, 12 into 25 is 300. So the answer is 300. Next, decorator buys 150 LED lights. So 150 is 15 into 10. So 3 into 5, 2 into 5. So 3 into 2 into 5 into 5 is LED lights. Next, sealed box contains certain number of marbles. 3 into 3, 9. 9 into 14. 9 into 7 into 14. 14 into 9 is 140 minus 14. 126. So the number of marbles are 126. Now, please take a screenshot of it so we can continue. Yep, thank you. Now, the uses of prime factorization. There are many uses of prime factorization, but we mainly use it in this chapter to find the HCF, to find the LCM, to find whether two numbers are co-prime, and to find whether one number is divisible by another number. So if we want to find HCF, we first prime factorize them and then we multiply the common primes. One point we need to remember is if the common primes come two times, then we have to multiply two times. Suppose we have 36, we can find that 2 comes two times in commonly in both of them. So 2 into 2 into only one time 3, so 3. So 2 into 2 into 3, 4 into 3, which is 12. So that's the HCF. For LCM, we take the highest squares. Suppose in 12, 2 comes 2 times, then 3. So we take 2. 2 into 2, 4. Next, 2 into 3 into 3. So 3 comes 2 times, so 3. So 4 into 9, 4 into 9 will be the LCM, which is 36. Like that, we are going to take which number comes more, that number we are going to multiply it and take it as the number for the calculation of LCM. Next, finding whether two numbers are co-prime or not using prime factorization method. Now, if if we do the prime factorization, we find any number common between them, so they are not co-prime. If we don't find any number between them, they are co-primes. Next, if we want to find out whether one number is divisible by another number, the smaller numbers should be there in the prime factors of the bigger numbers. Suppose 12 is 2 into 2 into 3. Now 168 has 2 into 2 into 3. Since both of them are there, we can say that 168 is divisible by 12. But in 75 and 35, 7 is not there but 5 is there. Since 7 is also not there, we should say that 75 is not divisible by 35. Now let's practice what we have learned. Rima has 84 centimeters of blue ribbon and 108 centimeters of red ribbon. Same question, but we have to use prime factorization. So what is 84? 84 is 2 into 2 into 3 into 7. 108 is 2 into 2 into, what is 108 by 4? 27. So 3 into 3 into 3. Now HCF means all the common ones. So 2, 2 and 3. So 12 is the answer. Find the maximum length of each piece, 12. Next, two decorative lights blink every at different intervals. One 12 seconds, one 18 seconds. 12 is 2 into 2 into 3. 18 is 2 into 3 into 3. So 2 square plus 3 square is 4 into 9, which is 36. 36 seconds. After 36 seconds, they will blink together. Next, a sports coach groups 45 players for warm ups and 28 players for skill drills. So 45 is 3 into 3 into 5. 28 is 2 into 2 into 3. So here we can see that 3 is common. So they are not co-prime. Next, a teacher claims a number is divisible by 9. She reveals only its prime factors. 3 into 3 into 5 into 2. 9 is 3 into 3. The number is 3 into 3 into 5 into 2. Since both the 3's are there and that number is there in that one, it is correct. The teacher is correct. Next, two buses leave station. Bus A completes round in 30 minutes. So 30 is 3 into 2 into 5 and 50 is 5 into 2 into 5. So when both buses return together at the station means LCM. LCM, for LCM we only have, all of them are different, so we can only take here 5 square is there, and then wait 1 second. Hmm. We can say that 300, 30 into 10, 300, 50 into 6, 300. So after that, we can see that both buses will return after 300. And then find HCF to understand largest equal time interval that divides both the schedules. So HCF, we all know the common ones. 5 is common and 2 is common. So 10. So the largest equal time interval is 10. Next, a warehouse packs curtains in bundles of 72 and 120. So 72, I think we already did it. 2 into 2 into 3 into 3 into 3. No, 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 no. 2 into 2 into 2 into 3 into 3. And then 120 is 2 into 2 into 3 into 5 into 2. Yes, wonderful. So, whether one number is divisible by other, No. And then how many prime factors they share? One, two, three, four. They share four prime factors. And then besides two or three, no, they don't share any common factor. Yeah, so please take a screenshot of this so you can practice it later using all the explanations that we have given in this video. And next, divisibility tests. So a divisibility test is a quick rule that tells you whether one number can be divided by another number. So if we want to know whether 4 is divisible by 2, what do? We usually do 4 by 2 is 2. But when we have 5269 divided by 3, it is going to be hard. So we can't do long division for that. So we have to use divisibility tests. So for the first one, divisibility by 1, every number is divisible by 1. And the answer is the number itself. We have learned this as a property. Next, divisibility by 2. If the last digit is an even number, it is divisible by 2. Next, if the sum of all the digits of the number is multiple of 3. Suppose we take 369. So 3 plus 6, 9, 9 plus 9, 18. Now 18 is divisible by 3. 18 by 3 is 6. So 369 is divisible by 3. Next, divisibility by 4. If the last two digits are divisible by 4, then the number is divisible by 4. Suppose we have 764. Now 64 is divisible by uh, 4. 64 by 4 is 16. So the answer is correct and 764 can be divided by 64. Next, divisibility by 5. Suppose we have 525 and 620. If it ends with 5, it's divisible by 5. If it ends with 0 also, it's divisible by 5. Next, divisibility by 6. If it is divisible by 2 and divisible by 3, then it is divisible by 2 into 3, 6. Suppose we have 264. Yeah, 264 last digit is even, so it can be divisible by 2. 2 plus 6, 8. 8 plus 4, 12. 12 is divisible by 3, so 264 divisible by 3. So the whole number is divisible by 6. Now, divisibility by 7 is a bit tricky. Suppose we take 49 and here we have to take the last digit 9. 9 into 2 is 18. So 49 minus 18 is 31. One second. Sorry, we have to subtract with the remaining number. So 63, we take 3, we double it 6. So 6 minus 6, 0. If 0 we get, 0 is 7 into 0. So it's divisible by 7. So the original number is also divisible by 7. Now let's take a better example. Let's take 35. 5 into 2, 10. So 3 minus 10 is minus 7. So minus 7 is 7 into minus 1. So that's also correct. Next, divisibility by 8. If the last three digits of the number are divisible by 8, then the number is divisible by 8. Suppose we have 5800. 800, the last three digits are divisible by 8. So the whole number is 5800 divisible by 8. Divisibility by 9. It is just like 3, but the sum of all the digits should be divisible by 9 also. Only 9. It should be divisible only by 9. Then the number is divisible by 9. And divisibility by 10, if the last number is 0, if the last digit is 0, then the number is divisible by 10. Now, let's practice what we have learned. But before, please take the screenshot so that you can practice afterwards. These questions are specially curated by me, and these questions are most probable for coming in the exam. So please practice. Now, the first question. A shopkeeper has 250 pens. He wants to pack them in boxes that each hold 10 pens. Use divisibility test for 2. 0 is even, so it can be divisible. And 5. The last number is 0, so it can be divisible. Next, school receives 243 entries for music contest in two groups of 3. So use divisibility test for 3. 2 plus 4, 6. 6 plus 3, 9. 9 is divisible by 3, so 243 is divisible by 3. Each group will have same number of participants. Next, 1368 rows of 4. Now 68, as we all know, is 17 into 4. So it can be divisible. 1368 can be divisible as we did the divisibility test now. So the arrangement is possible without leaving anyone out. Now 1062 and each shelf holds 9 books. 1 plus 6, 7, 7 plus 2, 9. 9 divided by 9 is 1. It can be divisible. So yes, the books can be divided exactly. It passed the divisibility test for 9. Now, a class has 174 students and divisible by 6. So, 4 is even. So, 2 divisibility test undergone, and 1 plus 7, 8, 8 plus 4, 12. 12 is a multiple of 3, so it can be divisible by 3. So, 2 into 3, 6. 174 can be divided by 6. Next, number on a board reads 532. It is divisible by 7. Teacher isn't convinced. She only doesn't know. Now 532, if we take 2 and double it, it becomes 4. So 53 minus 4 is 49. We know that 49 is 7 into 7. So the student is right, the teacher is wrong. Now, mm, challenge of the chapter. This question is a bit hard. So, if you have understood the whole chapter, you will be able to complete this. And if you have been able to complete this question, I am guaranteeing you that you will get very good marks in your exam. In your exam on this chapter, you will get very good marks if you have been able to complete this question. Now, a school is preparing gift packs for a maths festival. They have three types of items: 84 stickers, 90 badges, and 70 pencils. The teacher wants to make identical gift packs using all the items with nothing left over. But here's the twist, she has certain conditions. Before packing, she checks whether 84, 90, and 70 are prime, composite, or co-prime. So your part is to classify each pair. You have to tell us whether 84 and 90, 90 and 70, and 70 and 84 are prime, composite, or co-prime. Next, she decides to find the HCF of those three quantities. So find the HCF. Next, she wants to find the LCM, and the next one she wants each gift pack to be divisible by 6, 9, and 10, each number of items in each pack. So, based on the HCF you found, which all those will all those numbers satisfy those conditions or not is what we have to justify. Next, the teacher writes a mystery number on the board, 2576. She asks us, is it prime or composite? You have to tell her. And is it divisible by 2, 4, 5, 8, or 9? And next, is it co-prime with 90? So this is the whole question. Please take a screenshot so that you can practice it afterwards. Now, the final one. Thank you. And please like, share, and subscribe to my YouTube channel. I am sorry if I have not answered any questions or have gotten confused and given the wrong answers. If I have misspelled something or have forgotten something, I'm very sorry. If you want, you can look at my video again and then you can ask me for doubts in the comments below. Please study well. I really hope you get good marks in this chapter's exam. Please like, share, and subscribe. Thank you for watching. This is Akhil Jain signing off.